guys, welcome back. Just to refresh your memory, here's the engineering design process. Remember, there are 6 stages beginning with ask, imagine, plan, create, improve, and share. Don't forget, these stages are iterative, meaning that you can move freely between each step as you work to create your solution. Today, we're going to focus on the ask stage. In this stage of the engineering design process, we will work together to define our problem and to identify some criteria and constraints in developing our solution. Do you remember what our problem was? Right, we live in this beautiful waterside home and a hurricane is headed our way. But, what exactly is a hurricane? How do hurricanes form? What kinds of damage does a hurricane do? Hurricanes are large, violent storms that form over the ocean. Warm, moist air above the ocean water rises. This causes a low pressure to form beneath the warm air. This new air from the low pressure becomes warm and moist from the ocean water, which causes it to rise again. As the air rises, surrounding air swirls begin to form, and this process of rising air continues. The moisture in the air creates clouds, and soon the entire system begins to spin in a counterclockwise direction. The spinning creates very, very strong winds. Hurricane force winds can range from 74 miles per hour to over 160 miles per hour. These winds often bring very large tidal waves towards the shore. This is called a storm surge. To learn more information about the damage these strong winds and storm surges can cause, we will look at some video footage from a very specific hurricane that you might have even heard of before. Hurricane Katrina hit New Orleans, Louisiana on August 29, 2005. When it made landfall, it was a Category 4 hurricane, meaning the winds were moving just over 140 miles per hour. Take a moment to watch this short video clip from when Hurricane Katrina made landfall.
As dawn breaks, Katrina's wind speeds slow back down to a Category 4 hurricane. It makes landfall at 6 a.m., 60 miles southeast of New Orleans. Its 140-mile-an-hour winds pummel the coasts of Louisiana, Mississippi, and Alabama. The eye of the storm moves just east of New Orleans, but the city is not spared. New Orleans sits below sea level, surrounded by Lake Pontchartrain and the Mississippi River. High flood walls called levees keep the water at bay. But by 8 a.m., there are reports that a levee has broken. The waters of Lake Pontchartrain rush in. Levees in 3 locations are breached. 80% of the city is flooded. Some neighborhoods are submerged under 20 feet of water. As night falls, Katrina slows to a tropical storm. It heads north through Tennessee and into Kentucky.
What did you notice during that video clip? What did you wonder? I noticed that there were some extremely strong winds, and those strong winds were pushing the water. This made the water move very fast through the streets. I even saw a car. A car! It was being pushed by the wind and the water. And that makes me wonder, how did that car get there? Was anyone inside the car? Is their house nearby? Were they able to stay safe? I sure hope that they were. Here you will see an aerial image taken by a drone of a neighborhood in the New Orleans area shortly after Hurricane Katrina passed. Look closely at that image. What do you see? What are those little rectangular shapes you see floating above the water? Wow, those are houses. What kind of damages do you think the storm surge caused to those houses? We definitely don't want that to happen to our waterside home. So let's get to it and start developing our criteria. Since we now know that hurricanes bring damages from both wind and water, we need to decide which we will focus on. I think since our house is right on the water, that we should focus on the damages that will come from the inevitable storm surge that the hurricane will bring. Our goal for our solution is to protect our home from the storm surge. Now that we have our criteria, let's talk constraints. We don't have the ability to actually go out and visit this house to build a permanent solution. So instead, we're going to create prototypes. Prototypes are small, simple models that will allow us to test out our ideas. This means that we are limited to using the materials that we have around our house. Today, here's your challenge. Find the same friend or family member. Ask them if they know of any solutions that are currently in place that will prevent damages from a storm surge or extreme flooding. You might even choose to research your own existing solutions. Use your notebook to write down any solutions that you discover. Or maybe you have other solution ideas. I can't wait to see how you bring these ideas to life as you work to engineer your solution.